Let's talk about how AI agents actually get stuff done. It's so easy to picture them as these all-powerful, all-knowing brains, but the real secret sauce, the thing that turns them from a brain in a jar into an actor on the world stage, is something surprisingly down to earth. They're tools. So let's get into it.
Okay, so let's start with a thought experiment. Imagine you have the smartest, most sophisticated large language model on the planet, but it's totally isolated. No internet, no connections, nothing. What can it really do?
The answer? Honestly, not a whole lot. It can't look up the weather for you, it can't order you a pizza, and it definitely can't check your company's latest sales figures. It's this brilliant mind, but it's effectively trapped inside a digital box.
So here's our roadmap for this explainer. We're going to see how we can give that brain some hands and eyes. We'll kick things off with why agents need tools in the first place. Then we'll get practical and see how simple code becomes a tool. We'll level up and talk about agents using other agents, which leads us to a huge industry-wide headache called the N times M problem. And that's where a universal language called MCP comes in. Finally, we'll wrap up by looking at the incredible potential and the very real dangers of all this.
All right, first things first. Why is this even a thing? Why do agents need tools at all? Well, it's all about breaking them out of that digital prison we just talked about.
You see, a standard large language model is basically frozen in time. Its entire universe is the data it was trained on, so its knowledge has a hard cutoff date. It has no idea what happened in the news this morning, and it can't take any action in the real world. Tools are the bridge from its static internal world to the dynamic real world we live in. They are what let it out of the jar.
So, how do we start building that bridge? How do we give this brain some hands? That brings us right to our second section, turning a simple piece of code into a powerful tool the agent can actually use.
And you know what? It's probably way easier than you think. In a modern framework, it's basically a three-step dance. 1. You write a totally normal Python function. 2. You describe what it does in plain English. 3. You just tell the agent, hey, this new tool is available for you. That's it. You could build a currency converter tool in just a few minutes.
Now pay close attention to this part, the docstring, that little description there. This isn't just a note for other programmers. This is, and I mean this literally, the instruction manual for the AI. The agent reads this description to figure out what the tool does, what it needs to run, and most importantly, when it's the right tool for the job. It's absolutely critical.
Okay, so giving our agent a basic tool is one thing, but what about tasks that the main AI just isn't that good at? This is where things get really interesting, using other, more specialized agents as tools themselves.
Here's a little secret. LLMs are wizards with words, but they can be surprisingly shaky with precise math. Ask one a complex arithmetic problem, and it might just hallucinate an answer. But you know what's perfect at math? A calculator, or better yet, code. So the smart move is to delegate. Instead of asking our main agent to do the math, we give it a specialist calculation agent tool that just executes code and returns a perfect, reliable answer every single time. And it's really important to get the difference between these two concepts. When an agent uses another agent as a tool, that's delegation. The main agent is still the boss. It asks for help, gets an answer, and carries on. That's totally different from a sub-agent, which is a complete handoff. That's like Agent A saying, I'm out, you take it from here, and Agent B takes over the whole conversation. Two very different ways of working together.
Okay, let's zoom out. We've been looking at individual agents, but what happens when you have dozens of different AI models and thousands of potential tools? Well, you run headfirst into a massive, massive problem. It's called the N by M integration problem. Just imagine, for every one of your N AI models, you have to build a custom piece of code to connect it to every one of your M tools. The math gets ugly fast. Add one new model, and you have to build M new connectors. Add one new tool, and you have to build N new connectors. It's a chaotic, unscalable mess.
So how do you fix that chaos? You do what we've always done in tech. You create a standard, a universal language that everyone agrees to speak. And that brings us to the Model Context Protocol, or MCP.
Think of MCP as the USB port for AI agents. It's an open standard that basically says, look, as long as we all format our conversations in this specific way, any agent can talk to any tool, right out of the box. No more custom connectors. It's the key to a true plug-and-play ecosystem.
And the architecture is actually pretty simple to wrap your head around. You've got the host, that's your main app, the thing the user sees. Inside the host is the MCP client, which does the talking. And it talks to an MCP server, which is the thing that actually offers up the tools, whether that's connecting to a database or letting you commit code to GitHub.
Now, the official MCP white paper talks about a bunch of different capabilities, things like sharing prompts and resources. But if you look at the data on who's actually using what, well, the numbers speak for themselves. Look at that top line, tools. At 99% support, it is overwhelmingly the killer feature. This is what MCP is all about.
So MCP seems like a game changer, right? A universal standard that unlocks this amazing ecosystem. And it is. But like any really powerful new technology, it's a double-edged sword. It has incredible promise, but it also has some very sharp edges.
The upside is massive. Your development speed goes through the roof because you're just snapping together pre-built tools. Your whole system is more flexible and resilient. And maybe most importantly for big companies, it gives you one single choke point where you can enforce security rules and governance.
But let's talk about those sharp edges. One of the big risks is something called tool shadowing. This is where a hacker creates a malicious tool but gives it a really helpful-sounding description. The agent, trying its best to help you, sees the description, thinks, oh, that's exactly what the user wants, and picks the malicious tool, sending your private data straight to the attacker.
And then you have a classic computer science vulnerability that's found a scary new life in the world of AI, the confused deputy attack. In this scenario, the AI agent is the confused party. An attacker tricks the agent into making a request to a powerful, high-privileged MCP server, the deputy. The server sees the request coming from a trusted agent and just does it, not realizing it's been manipulated into doing something it shouldn't, like deleting a critical database.
And all of this leads us to the big, overarching question we have to grapple with. As we make these tools universal and plug and play, are we just building smarter, more helpful assistants? Or are we, at the same time, accidentally engineering a brand new and incredibly complex landscape of security threats? The honest answer is, we're almost certainly doing both.